Hi, this is Hani again with my binary search tree. And in my previous video, I showed you how we did collision detection or interference detection. So we prevented the nodes from basically going on top of each other. So now, now that that's been fixed, I'm just gonna generate an integer array of 100 elements and let it generate. And I'm going to run it a few times and watch the beauty. I find it very soothing. So I'm going to be using Bash to run it 25 times, and it'll go really fast and it's very soothing to the eyes. I'll be quiet so we can enjoy the electronic art, if you will. So I am adding a delay in here because otherwise it'll be too hard on the human eye to follow. So the delay is zero point 0.1 second. It's really nice to see what the random number generator gives you. And again, it's 100 integer in an array, and I shuffle it. I say, give me 100 integer in this array. Go ahead and shuffle it and insert it. And this binary search tree does an in order insert, of course. So it's gonna grab the first element from the array and insert it, but the insert would be in order because it's a binary search tree after all. I just love to see how the tree resizes itself and spreads itself to extends itself to the right. So this kind of demonstration I could not do on CodaPad because CodaPad puts the limit on the amount of outputs I do, and also it puts the limit on the width of the terminal screen. I'm in here running it on my terminal using good old RSpec, and I used the bash script to run it 25 times. This is like electronic arts for my eyes. It's so soothing watching it find, as it's inserting the nodes, finding uh, shifting the tree to the right just to kind of elbow in a position for the nodes. Wow. So in a future video, I am going to show how to do an orderly dispose of the elements of the tree. So basically, we want to traverse the tree and from the leaves, go through the leaves and do leaves left to right leaves traverse and dispose, and then go up and dispose of the element. And I'm not sure if that's the best way. It could be an in order traverse, maybe the way to go, post or pre-order. I'll have to think about it, but the idea is we want to get in the habit of disposing of all those elements that we created, and I want to just zap the memory so we can recover the memory. Now you'd say, okay, the garbage collector would take care of that. Yeah, it is true, but in a large complex application that's gonna, for example, a website where you have complex interrelated data structure, The garbage collector may not get to deleting all the elements. So it's always good and helpful to give the garbage collector hints that it's time to go ahead and delete it by nullifying those objects you've created. I also want to expand this tree to be a balanced tree. So I've been researching the difference between AVL trees and red-black trees, and I'm not sure which is better. But back when I was in college, AVL trees were the balanced trees, the balanced binary search trees, and then I look now and they've been superseded. Everybody's talking red-black trees, or sometimes, oh gosh, I've heard 2, 3, 4 trees, but I'm not sure what those are. Okay, we're done. I thank you for watching. I enjoyed it. I think this is something I can probably put it in loop and run it a few thousand times and create a YouTube video and and have it very soothing for the eye.